Hello friends. Today we're going to discuss about a topic on Kubernetes, which is a deep dive. So as you already see that Kubernetes breakdown, like how you break your Kubernetes cluster from the scratch and what are the components were available, how the applications are working inside the Kubernetes. I have already explained in a basic format in my previous video, but now some of my subscribers were asking like, can you do some more deep dive on explaining the concepts in deep? So for their request, I'm just doing this recording for doing a Kubernetes deep dive. Hi, this is Venkatesh. Welcome to SmartDevops. And today we are going to discuss about the Kubernetes deep dive. If you want to understand Kubernetes in very detail, please don't skip it and watch this video till the end. So I'm going to cover each component very clearly and how the components were working when you do any deployments. So let's jump into it. So in Kubernetes, as you know, first before going into the components, the Kubernetes. So what is Kubernetes first of all? So Kubernetes we'll call it as a K8s. That means if you know there are how many letters here? 1, 2, 3, 4, 5, 6, 7, 8. So we call it as 8KS. So in short form, we call it as a K8s. So in this video, so I'm going to call Kubernetes as K8s. So just bear with me. And then let's see what is actually a Kubernetes. So Kubernetes is an orchestration tool. What it means? What is the meaning of an orchestration? So that means a tool which is doing an automation and which can do scalability and provide a availability. So if any tool providing these three, that we call it as an orchestration tool. Okay. So that's why Kubernetes is calling as an orchestration tool and more usage in our organizations for doing a big deployments to do continuous deployments into our environment. But before going to the Kubernetes in deep, my only suggestion here is what are the prerequisites to be taken to understand Kubernetes. So the prerequisites are we need to have a basic understanding of Linux and shell commands and also a knowledge on Docker and networking. So these are a prerequisites before going to start Kubernetes. And what are the different flavors of Kubernetes available? That I'm going to cover it here. The different flavors of K8s for basics, like for if you want to start as a beginner, if you want to understand Kubernetes in your mission, then there is called Minikube. So this is just a basics I'm telling you. We can make use of Minikube to understand what is Kubernetes in your. If you want to understand like what are the how to use Kubernetes and what is actually a Kubernetes is, then you can make use of Minikube and it will work on any OS, either it is a Linux, Mac OS or Windows. Okay, different flavors available. I will provide the documentation on how to install Minikube and how to make use of it. Once we move to an advanced version, advanced like you know what is Kubernetes, then you can go with creating a single node, okay, or multi-node clusters, and also you can jump into the EKS in cloud, AKS and GKE. So this is about the flavors of Kubernetes available and how you can make yourself comfortable like as a beginner, and once you know the concept how we can move to the advanced stage. Now let's jump into the core components of Kubernetes. So the core components of Kubernetes. Okay, so when you want to utilize Kubernetes, we need to have a server first. Okay, somewhere you have to install Kubernetes, right? So to maintain that one, we can go with the here Kubernetes work as a master and worker concept. That means you can have your a node which act as master or control plane worker. You can have a number of workers, but for understanding, I just created one worker. So the request and response are happening between this master and worker node. How it is happening? What are the components were configured inside this master and worker and how these connections were going on. Coming to the concepts like in master, we have The number one component is API server. Number two, etcd. Number three, controller. Four, scheduler. So these are comes under master node. What will comes under worker node? Proxy, kubelet, and either a Docker or containerd as a CRI, container runtime interfaces. Okay, good. So what is the usage of each component here? What is the functionality it will do? So for example, when you install Kubernetes, how the communication is happening? So when you open your page, when you open a console or a CLI and you are running a command kubectl using some kubectl command. I'll tell you what is kubectl is like a, it's just a binary you have to install to communicate to your cluster. Okay, like how you can install for AWS, there is a AWS CLI for each component. Nowadays what we are going to install, they are having their own CLIs to communicate to that component. So that is kubectl. We can install it and we can communicate to the master. Now when you run the command, some communication is going from here to API server. So the main purpose of API server is the request coming from the master, whoever is running the kubectl commands here, the request has to come here and it will hit the API server and it will send that request to kubelet and it will ask, hey kubelet, I have a request from the master, so and so kubectl request. What is the response of that one? Now the kubelet will provide the response back to the API server and it will provide you the output in the screen. So that is the communication between API server and kubelet. Next, coming to etcd, it's like a etcd is nothing but a storage, I can say like a storage of cluster details. It will be like a key value pair. Okay, that's it about the etcd. Like what it's like a, you can imagine like a db where you have all your data about your cluster. Next, controller. What is a controller? Is like in the name itself it is telling you it which will control and make your desired state of your application. That means imagine you are running a, your node is running with one master and one worker. So this is your desired state. So the purpose of the controller is to maintain this desired state until the end. That means it has to maintain this copy till the end. If there is any fluctuations, it will bring back to the desired state. Okay. So that is a desired state. When you build your cluster, that will be your desired state. It has to make your state to be stable. Scheduler. The name itself will telling you that scheduler, which will schedule and it will first look for the available. For example, you have one master, one node. If you want to deploy your pods here, it will look for the available nodes to deploy your pods. Okay, that is the usage of scheduler. Next, kube proxy. So the kube proxy is the, suppose if you have two pods, the networking between these two will be maintained by the kube proxy. Okay, and then kubelet, as I said, like it's running as a service in your worker node. To the kubelet is a main service running in your worker node to provide the response like heartbeat to your API server stating yes, I am healthy from this certain worker node. I am going to provide you the response to this API server. Imagine you have three worker nodes, and when you run the API server command, you should be knowing that where is your pod is running, right? So that data will be provided by kubelet to the API server. Okay, that is the importance of kubelet. As you know, Docker and containerd, that is to create an Docker service in your worker nodes to pull your images with required images to your worker nodes and keep that images to be available when your application started running. These are the core components of Kubernetes. So as I summarize, I'll tell you API server, which will take the API request from the master and send that to kubelet and provide the response back to the user. HCD is a storage which will have your distributed key value storage of all the cluster information. Controller to maintain the desired state of the cluster, and scheduler which will schedule your pods by seeing the availability of the node. Coming to the worker node, we have kubeproxy to maintain the networking between your pods. Kubelet is a service to provide the heartbeat to your API server, and Docker containerd is to maintain your images and to run the application. Next, going to that next topic, and there is one more question to you people when you are watching this video. Here I said like one master, one worker, right? There is a concept called raft algorithm. How many people aware of this raft algorithm? Please comment out and explain what is a raft algorithm and how the raft algorithm plays a role here to maintain your cluster node like master and workers. Okay. And the next comes like when you have your master and worker is ready. Now imagine if you want to do a deployment. That means before going to the deployments, as I said in my previous video, the core components of an application deployments will be divided into three pods in Kubernetes. That is pod or pods, replicas, deployments. These are the core, I can say. Okay. So what is a pod? Imagine you have an image developed and pushed to Docker. Using this image, you have to bring up your pod. Okay. Your pod is running now. Okay. It's running. As I said in the definition of Kubernetes orchestration, it has to provide what? Availability, automation, and scalability, right? So to maintain that one, the replicas, we can provide how many replicas. That means you have one pod, two pods, or three pods. You can decide based upon your traffic and give the count of replicas, how many pods you have to run. Pod count, if you provide two pods, will start running. Pod one, pod two. Okay. And then this is to provide the availability, and deployments is the combination of these two pods and replicas. Why I'm telling combination in the sense deployments will provide here we can involve like so many environment variables like config maps and secrets to your pod and then deploy. Okay. While deploying, as I said, like the deployments you have decided as two. Now your two pods will start running as a healthy. Okay, these are the core components inside your cluster running when you deploy an application. Okay, imagine if you have an nginx deployment. Okay, when you do nginx deployment, you decide how many replicas you want. You decide as a two. Now two pods will start running and healthy. Okay, this is about the pods, replicas, and deployments. Next, you have your pods running and how you can expose this application to the external. That means, for example, you pod running here, running. When you start running the pod, okay, you have to attach this pod or deployment to a service. Okay, in Kubernetes, we have three flavors of services. One is cluster IP, node port, and load balancer. So I'll brief about this one. Cluster IP is like a default service when you start any pod in your cluster. For example, if you install Kubernetes, default Kubernetes service will come as a cluster IP, which will be connected to internal cluster. Node port, you can define your port number. Okay, you can define your port number and expose your application to the external world. In the load balancer, you can have your own load balancers attached to your service, like using a AWS or on-prem. Okay, you can use it and expose your application via load balancer. Now, when you run Nginx deployment, that Nginx deployment will be mapped to a service and that service will be exposed to the external world. Now, when you hit that URL, you can see the response like. So I'll give you a demo on this one for a better understanding. Okay. So these are the basic components, guys. Pods, replicas, deployments, and services. There is some more components were available like a configuration map, secrets, volumes. Okay. So I'm going to cover it as a part two for this video. If you like this video, please like, share, and subscribe. And if you have any questions, please share your questions in the comment box. I'm happy to respond to you. And thanks for support. Thanks for watching. Bye. Here is a quick recording of how to do the deployments. So now I have Nginx deployment here. Let me explain you what is this here. So this is a deployment file and I'm going to use an Nginx latest image. Okay. And the respective deployment file is this one and I am using a service to expose the application to the external world. So here I have given target port as 80, but you can get anything. So now you can see by using this port number 30523 with my host name, I'm able to get the response as hello from Nginx. So that's it for this demo. See you in the next video. Thank you.